Hello everyone, today we are here to discuss the lead topic, Sustainable Sites, section Heat Island Reduction. Let's start with the definition of heat island effect. It is the thermal absorption by hardscape such as dark, non-reflective pavement and buildings and its subsequent radiation to surrounding areas. As we can see in the picture, urban areas are warmer than rural areas due to the absence of green spaces. This is why there is a thermal gradient differences between developed and underdeveloped areas.
So, what is the purpose of this LEED credit? By reducing these differences, we can minimize the impact on microclimate, human, and wildlife habitats. This heat island may contribute to regional average warming trends. Urban heat island effects have many negative consequences.
First, plants and animals sensitive to temperature fluctuations may find habitat inhospitable. Second, human health may suffer because exposure to ground-level pollution is often worse in places affected by heat islands.
Heat islands increase cooling loads in the summer, necessitating larger, more powerful air conditioners that use more electricity, in turn increasing cooling costs, producing more greenhouse gases, and generating more pollution. SRI is another terminology that should be defined. A roofing material's ability to reject solar heat is the Solar Reflectance Index. In this table, we can see SRI value of different materials. As you can see in this picture, the dark roof with no protection has the lowest SRI value, while the roof with white ceramic has the highest SRI value because white color reflects more light.
Solar reflectance, or SR, is used to measure the solar heat rejection of components that are not roofing materials, or non-roof. For example, vegetation, shading devices, and other less reflective components. SR is a more appropriate way to measure non-roof materials, which have more thermal mass. It should be mentioned that both SR and SRI are calculated according to ASTM standards. This credit considers a product's 3-year aged SR or SRI values, which measure materials' performance over time. The credit encourages project teams to adopt a variety of strategies, including reducing hardscape and incorporating high SRI or high SR materials such as vegetation and shaded parking, which minimize a project's overall contribution to heat island effects.
Hardscape includes all paved roads, sidewalks, courtyards, and parking lots. For achieving this credit, there are two options. Option 1 is for projects with compliant roofs and upgrade systems without covered parking. It should be mentioned that minimizing hardscape and increasing landscape portion of the site is the most effective strategy for reducing heat island effects. Roofing material selection is typically the most economical way to mitigate heat island effect. We should consider how roof surfaces will be maintained. For example, regular cleaning will be needed to maintain the reflectivity of high SRI surfaces. Effects of glare on traffic, pedestrians, and adjacent buildings, especially if project has steep, sloped roofs, should be considered as well. There are two equations associated with option 1. First one is used for determining the combined compliance of roof and non-roof measures for the whole project. Equation 2 is useful for projects that have multiple roof angles. It is also used for non-roof or roof materials that fall both above and below the required SR and SRI values. In the calculation of applicable roof area, we should exclude roof area covered by mechanical equipment, solar energy panels, skylights, and any other appurtenances.
Option 2 is for projects with only covered or underground parking. Here some tips should be mentioned. Calculate the number of parking spaces within the lead project boundary. It is important to know that bicycle parking spaces cannot be counted. At least 75% of parking spaces has to be located under cover. If it is possible, locate parking spaces underground, under a deck, under a roof, or under a building. Count uncovered parking at the top level of the multi-level parking structure as uncovered spaces in the credit calculations. Ensure that the roof over the parking area meets the credit requirements for eligible types of parking cover.
We have found some lead GA questions related to this topic that can be helpful. First one. What will a project team use to compare different products' abilities to reject solar heat? The possible options are emissivity, perviousness, solar reflected index, or albedo. The answer is solar reflected index.
The second question is, which of the following does not help reducing the non-roof heat island effect? Placing parking under cover, increasing the number of above-ground parking spaces, planting large non-native trees for shading, using paving materials with high SRI values. The answer is increasing the number of above-ground parking spaces. We hope you enjoyed the topic. Thank you.